Okay, tell me something about box and whisker plots now. Tell me, what does a box and whisker plot do to the data set? Going to give us a general idea? In other words, if I told you to take all the grades you've gotten for the whole year and make it into, I want you to write down every percentage that you got, and I want you to make a box and whisker plot with it. What would you be doing with that data set? Be putting it in order. So you need it in order first of all, because a box and whisker plot shows the data from smallest to largest. Does it show it somehow? From smallest to largest? Can you, in other words, Riley, can you pick out the smallest data value and the largest data value looking at a box and whisker plot? Say that for me. Can you? Yeah? Okay. How many of you agree? Riley says yes. Look at a box and whisker plot. You can tell what the smallest data value and what the largest was. Okay? Yeah, you're right. In fact, those are the endpoints of our whiskers. The beginning of the whisker at the left end is the smallest data value. The end of the whisker at the right end is the end of the largest whisker. The whisker at that end is the largest data value. Okay, so now we say, well, guess what? We can look at our box and whisker plot and we can say, here's what the smallest data value was, here's what the largest was, here's what my smallest quiz score was or grade was, here's what my largest was. What else can we tell from a box and whisker plot? What else did it say you could tell? Right? The median. In fact, where is the median in a box and whisker plot? Where's it at? It's in the middle of where, though? Is it real? It's the middle of the data set, but is it in the? Does it have to be right exactly in the middle of the box and whisker plot itself?
No.
No. Where's it at? It's inside the box somewhere, isn't it? Does it have to divide the box exactly in half? What do you think? No, it doesn't. No. But you can get the median by looking at that line that goes, that little vertical line segment that's inside the box. That's your median. So you can look at it and say, oh, there's my median quiz score. What else can you tell? What else does a box and whisker plot do? Stefan? First quartile, you're right. That's what you say, quartile. It divides it into quartile. So is there a first quartile, a second quartile, a third quartile, and a fourth quartile? Hey, what's the lower whisker? Which quartile do you think that one is? First quartile. Even though there's a data point, we call the quartile one data point. There's that box, that first whisker is the first 25% of the data. So if you have, I don't know, let's say you have 20 grades. I mean, I know you have more than that for the whole year, but let's say you have 20 grades. How many grades would be represented in that lower whisker, that first quartile? How many?
5.
How'd you get that?
Divided by 4.
Divided by 4, because there should be 4 quartiles, right? So there should be 5 data values represented in the lower whisker. How many would be represented in what we call the lower box? How many would be represented there? That's another quartile. There'd be another 5 represented there. Then there's called the upper box. And there'd be another 5 data values represented there. That's the third quartile. And then there's that upper whisker. And that would be another 5 data values. In other words, it takes the data and divides it into like kind of like quarters. Think of it. There's 4 quarters in a dollar. It's kind of like saying this first whisker is 25% of the data. The lower box is the next 25%. The upper box is the next 25%, and that upper whisker is the last 25%. When they don't have a pink pass, they don't call them out. They're really responsible for them. So can you just make sure that she's supposed to do these? Not that I don't trust you, Emerson, but you're my responsibility. Okay. So, what we're going to be doing is we're going to have to find some points, some data values that will help us make the box and whisker plot. And some of these names are going to kind of almost be like interchangeable. You like, I thought you called the lower whisker the first quartile. Well, I am gonna call it the first quartile, but there's something else we're also gonna call that, so, I haven't given you the note yet, have I? We're going to take a data set on the front side here to start with, and thank goodness it doesn't have a whole lot of members, which will make it a little bit easier to do, won't be quite as long. Because the most important thing that we have to do to even start this is we have to order the data sets. We have to put it in order. We cannot skip this step, or we're not going to make a good box and whisker plot. So the shorter the data set, the less work we have to put it in order, right? Okay, what is the smallest data value in that set of data we have there?
15.
I don't see a 15.
36.
Which one? 31.
33.
I see a 33. Is there anything lower than a 33?
No, sir.
No? Okay. So 33 is going to start it out. And then what's going to be the next one?
36.
36. Okay. And next? 40. Okay. Do this neatly because we're going to use this list. It's going to be important to us. And then 45, we got that 45 at the end there. This is a huge, really important step here. We got to do it right. What's next? 50, okay. 52 next, okay. And then you said a 55. 62 and 65. Okay. Now, here's what I'm going to highly recommend you do. Count how many data pieces we started with, and make sure you have that many data pieces in your new list.
10. 9.
I got 9 in both of them. How about you?
Yeah.
You have 9 in both of them? Okay. So we need the smallest and the largest. Well, that's pretty easy now, isn't it? Hey, what is our smallest? What's our minimum we're going to call it?
33.
33. Let's go down here, and that's one of our 5 data points that we need, data values, I shouldn't say, it's one of our 5 data values that we need to help make the box and whisker plot. Now, the minimum will always be the lowest when it's in numerical order from least to greatest. What's our maximum? 65, the largest one, the other end of our data list. Okay, well, we already know how to find a median, don't we? We're good. How do we find the median? Because I'm going to pick on that one next. We're going to find the median. The middle one, right? So what we're going to do is we're going to say, I'm going to go from here in. Guess what it is? 50, isn't it? Yeah. And when there's an odd number of data values, you will always land on a data value for the median, won't you? Because it doesn't have anybody else to pair up with. So the median is 50. Okay, so remember that's that little vertical line segment in the box somewhere, remember? Okay, now we need the outsides of our box. So, and they are called the left-hand end of the box, that point that's going to help define where that is, it's called quartile 1. Or in other words, it kind of like goes from the lowest value to the end of the first quartile. It's representing the first quartile of the, so it's defining where that whisker is going to end and where the box is going to start. So how do we find that? How do we decide where that's going to be? No. What does the book say? Does it give you any clues what to do to find that quartile 1?
Subtract.
No, we don't do subtraction problem.
Identify the 5 new values.
Well, we've already got 3 of our 5 values, and we're trying to find the 4th and the 5th.
I'm gonna use a I don't know what this is.
So what we need to do is we need to find the median of the lower half. We need to find the median of the lower half. Well, when we're looking for the median of the lower half, by the way, you know what, let's help ourselves out a little bit here. Let's identify these things that we've already found. We found a median. Would you identify that, please? And then, you know, this was our max down over at this end. This is our max. And this down here is our min. And now we're trying to find the quartile 1 value, or in other words, where quartile 1 will end and the box will start. And we need to find the median of the lower half. So here's what we do. When the median is one of the data values, we throw it out now, and we say there are 4 data values in that lower half. So we're gonna throw that out, and we're not gonna use it, and we're gonna find the median of that lower half. So here we are, we're gonna say, we gotta go from here in, and here, oh, wait a minute, there's not a number here.
You have to have this.
So what do we have to do? We have to add those two together. So we say 36 plus 40 equals
66.
76. And 76 divided by 2 is 38. Or in other words, you know what? We worked way harder than we probably needed to. We needed to find halfway between 36 and 40. Anybody, you know that line you like to give me? It's just common sense, Mrs. Brand. Anybody's common sense kick in there and say it's 38? Before we even did all that? Yeah? So 38 is the median of the lower half. So what we're going to say that this right here is the median. I want you to put this in your notes. Median of lower half. And that is known as our quartile 1. Quartile 1 comes from the median of your lower half. So because the median of the whole data set was one of the data values, it was right there in the middle, we don't use it again, we kind of just ignore it and say, well, there's 4 on this side, there's 4 on that side, I'm going to find the median of those 4 at the lower half. So my quartile 1 value is 38. And now we have to find the other quartile value. So basically what we're going to have is from the minimum to here, that's called quartile 1. From the quartile 1 to the median, that's going to really be called quartile 2, but it's going to be the lower box. From the median to the quartile 3, that's going to be our quartile 3, but it's really also going to be called the upper box. And then from quartile 3 to the maximum, that's our upper whisker. We have our 4 parts using these 5 points to get them. So what's the median of this upper half? So we have to go here, here. Oh, we're going to meet in the middle between these two. That one's not quite as easy to see, is it? What is it? How'd you get that, Stefan?
Well, I did those as like, well, I did the same thing, but I was just adding.
Add them together, yeah. So what we'll do is we'll take 55, add it to 62, and what do we get when we add those two? 117, okay? And 117 divided by 2, 68, or 58, not 68. How about 58? 58 and a half, or 0.5, right? So let's see if that makes sense. 58.5 is 3.5 units more than 55. And then is 58.5, 3.5 units less than 62. Sure is. Well, I feel like we're in the middle of them. So we're going to say this is quartile 3, which is the median of the upper half. I want this in your notes. We just found quartile 3 value. The median of the upper half will always find you the quartile 3 value. And we said it is 58 and a half. Now I want us to notice something before we even make our box and whisker plot here. How many of those 5 values are actually, how many of those 5 values are actually from our data value list? They're also members of our data value list. Is 33?
Yes.
Yeah. Is 38? Is 38 a member of our data values? Is it actually one of them? No. How about 50, our median?
Yes.
Yeah. How about our quartile 3 value of 58.5? Is that one of our original 9 data values? No. How about our maximum?
Yes.
Okay. Now, here's the deal. Here's what I want you to realize. There are only 2 of them that have to be members of the data value set. Which 2 do you think they are?
The
The minimum and the maximum. The minimum and the maximum. The median, what if we would have had to do some averaging? What if we would have had to average? Would the median have been one of our data values? Not necessarily. Quartile 1 doesn't have to be, but it can be. It could turn out to be. Quartile 3 doesn't have to be, but it could turn out to be. The only 2 that have to be are the lowest and the highest. Okay? So these values don't have to be members of the data set, but they help us make the box and whisker plot that show the data set. So here's what we do. We make 5 points, and before I even hand these out, we're going to put 5 points on our graph right now. Okay? So here's what I want you to do is above, I want you to go like 2 lines above, and I want you to make them on this right here. So I'm going to do 33 right now, and I'm going to show you where I'm talking about. I want you to have it be. Okay? So here's what you have to do. I already made the number line for you. You have to make a good call where 33 is and go above it. Don't do it on the number line itself. Do it above the number line, and I have to go 2 lines up. Now I want you to plot those other 4 points on that same line. So we should have a nice horizontal behavior going on here. And then, I'm going to hand these out, but please don't use them yet until I show you how to. Then I want you to have to erase. After you have your 5 points, now we're going to create the box, which will then also define the whiskers for us, okay? So what I want you to do is I want you to take your protractor and use this edge as a straight edge, okay? And I want you to make we're gonna make the left end of our box, and we're gonna do it with this right through the second point. We're gonna go 1 line above and 1 line below. So we're going to go through the second point, our quartile 1 value. Our quartile 1 value always ends the first whisker and starts the box for us. Now we're going to draw a little vertical line segment also going through the median and also going through the quartile 3 value. So we're going to have those 3 points in the middle are going to have line segments through them. And now what I want you to do is I want you to now turn your protractor going the other way, and I want you to finish off your box, the top and the bottom of your box. And after the box is made, now we can draw our whiskers. We're going to have a whisker going from quartile 1 to the minimum, a whisker going from quartile 3 to the maximum, and we have our box and whisker plot. Great.
How come the whiskers don't go on the inside of the box?
Because it's a box and whisker plot, not a whisker plot with a box. I don't know. Okay, so the first whisker, the whisker at this end, the lower whisker we call it, represents 1/4 of the data. And so that the range of that first 1/4 of the data, the lowest 25% of the data, what's the range? What's the range for that first 25% of the data? What does range mean?
Biggest minus the smallest.
Yeah, biggest minus the smallest. And I just want you to tell me for the lower whisker. So what's the range of the first 25%, the lowest 25% of the data? What is it? Right?
33 to like 38.
38. Remember, this is 38, isn't it?
Yeah.
So 38 take away 33 is 5. So the range of the lower whisker is 5, whatever this data set is about. What's the range of the next 25%, the lower box? What's its range? 50 take away 38, how much is that? 12. A much bigger range, isn't it? But yet the same amount of data values are actually represented there. They're just more spread out. There's a range of 12. And notice the lower box is longer when you look at it going, it's longer than the whisker, isn't it? It has a bigger range. We should be able to tell that. Okay, how about the range of the third quartile, the from 50 to 75% of the data set? What's its range? No, right here, this upper box part. What's its range? 58 and a half, take away, Cam?
8.8.
8.5? How about 8.5? The range of that one is 8.5. The upper box has a width of 8.5 units. And how about the upper whisker? Malcolm, what's the range of the upper whisker? Upper whisker. The top 25% of the data. How are we finding this? Some of you are engaged and the rest of you don't give a hoot at all.
Subtracting like 50 and 65.
So 65, take away
15.
58.5. Anybody know what that is? 6.5. It has a range of 6.5. But yet they all represent the same amount of data values. Every one of them really represent 2 1/4 data values. But yet some of the values are more spread out. Okay? What are the only things you can say for sure, absolutely, in this one we said, what are the only data values that actually came from the data set? They actually are represented in our data set also. Brighton? The minimum and the maximum. And how about for this one, what else? The median it is actually also represented in our data set. Okay, let's go to the back side. And let's do one more really quick here. Use the data set to make a box and whisker plot. How many data values does this one have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Has an even number of data values. Okay, get them ordered. You do that on your own quickly. Get them in order. And what did I tell you to do after you get them in order? I said you always should make sure that you have what?
The same amount.
Same amount of data values. If you have 10 in the list to begin with, you better have 10 in this list also. Okay. Which are the ones we can find right away?
Minimum and maximum.
Minimum and the maximum. Okay, our minimum is
15.
15. Our maximum is
28.
28. Okay?
47.
So max, min. What do we find next? Our
quartile.
median. No, let's find the middle one next.
That's 16,
So-
16.
We're going to go in. It's going to be halfway between 24 and 25. Halfway between that is 24.5. This is our median. So 24.5, this time our median is not gonna be one of the data values. Quartile, yes, Trey?
Do we put like a little square around those two, and those two make up half? Like, those
Yeah, you
two
could do
go
that,
together?
because now, the median is not one of our data values, is it? So now what we could do is, Trace, is could we just put a square around these guys and say, there's my lower half? Yeah. And now we have to find the median of our lower half. So in other words, to find our quartile 1 value, we need the median of that set. So what's the median of the lower half? 16, 15 and 24 at the end, and then we come in, it's 18 and 16. 16 is the median of this one, so 16. So we had to find the median of the lower half. Now we need the median of the upper half. Which one is it?
26.
26 is the median of the upper half. So we're going to say that quartile 3 is the median of this side, and that is 26. So we have our 5 points that will help us make our box and whisker plot. That's great.
So then if the median is not part of the graph, then does that always mean that Q1 and Q3 will be a part of the graph?
Part of the data set. Because if we have an even number, so that leaves our halves having an odd number, so it looks like they would be, doesn't it? We should always land on the one in the middle should be one of our data values. Yeah, good observation. Okay, go ahead and make those 5 points. What did we do again? We made them two lines above. So you make your 5 points. Make a good judgment call where your values are at. Don't be haphazard, because when somebody reads this, they want to be able to tell. These guys are kind of close neighbors, aren't they, some of them? Okay, so you can start with the whiskers or you can start with the box. I started with the box last time, didn't I? If we want to start with the whiskers, we just are going to connect the first 2 points and the last 2 points. Those are our whiskers. And now the box goes around the rest of it. So we're going to have one observation you should be starting to make is, you know what, just because it's divided into 4 quartiles does not mean each of those quartiles is the same length. Because their ranges can vary. They have the same amount of data values represented in them, but that does not make their ranges the same. It depends on how close they are to each other within this set. That helps determine that.
Why is it 2 rows?
Why is there what? 2 lines.
Right.
So these guys?
Yeah.
Okay, this is kind of like what we call that one that this is the median, and you feel like it should be over more in the middle of the box, but because the median and quartile 3 are so close to each other, and because the median and quartile 1 are so far apart from each other, it ends up looking a little off like that. So what is the largest range here? Which quartile? Which quartile has the largest range? Quartile 2. This is quartile 1, the lower whisker. The lower box is quartile 2. The upper box is quartile 3, and the upper whisker is quartile 4. So quartile 3 has kind of like two roles. It plays the edge of the box, plus it's the third piece of the 25% of data. But from 50 to 75% of the data tray.
When you say upper and lower, are you referring to the replacing the number line?
Yes. So lower whisker is at the lower end of the number line, upper whisker is at the upper end, okay? Okay, and then we should be able to, in your homework, you might have to make some other, answer some other questions. I was just teaching you how to make the box and whisker plots, okay? Anybody have any questions? You have to make sure that you show the kinds of things we were showing here and identify those 5 points, because how easy would it be if you were just given the box and whisker plot and the number line below it? How easy would it be to be able to tell somebody what those 5 points are? On this one, do you think you could tell them exactly what the five data values were that helped you make the box and whisker plot? No, you couldn't. No, you couldn't. You would look at this and somebody might say, oh, that's 24. This one they might say, oh, that's 28 and a half. We can't tell so easily from the number line, the box and whisker plot itself, so I want to make sure that you're also showing me somewhere. So you're gonna need loose leaf paper to show your work on, and then you can make the box and whisker plots right on here because I provided the number lines for you to do it with. And there isn't like a lot, so you should be able to get this done even without getting homework time.